welcome to our pH meter demonstration. Today we'll walk you through the process of using a pH meter to measure the pH of different solutions. Along the way, we'll also cover some key concepts like behavior of strong and weak acids and how buffers work. Before we take any pH measurements, we need to calibrate the pH meter to ensure accurate readings. We begin by selecting two standard buffer solutions that are typically used for calibration. Today, we'll use pH 4.00 and pH 7.00 buffers. These are commonly used because they represent acidic and neutral pH values. First, we rinse the probe with distilled water to avoid contamination between solutions. Then we put the probe into pH 7 buffer solution and register it. Then we rinse the probe again and place it into the pH 4.0 buffer solution, and after that stabilizes, we calibrate the meter to read 4.0. This ensures that the meter can accurately measure acidic solutions as well. Now, let's talk about the difference between strong and weak acids. Strong acids, like hydrochloric acid, dissociate completely in water, meaning they release a large number of protons, lowering the pH significantly. On the other hand, weak acids, like acetic acid, only partially dissociate, so fewer protons are released, resulting in a higher pH for the same concentration. This difference in proton behavior is what causes strong acids to have a more dramatic effect on pH compared to weak acids. This can be explained by equilibrium, where the dissociation of weak acids is reversible, unlike strong acids. To minimize these effects, you can dilute the strong acids or use buffers to stabilize the pH. Now, let's talk about buffers. A buffer is a solution that resists changes in pH when small amounts of acid or base are added. They typically consist of a weak acid and its conjugate base or a weak base and its conjugate acid. They work by neutralizing added acids or bases. For example, when an acid is added, the base component of the buffer reacts with the hydrogen ions from the acid to reduce the pH change. Buffers are crucial for many processes, but they only work effectively within a certain pH range, which depends on the strength of the acid and base components. Buffer action relies on the ability of the weak acid and its conjugate base to counteract any changes in pH, keeping it within a narrow range. In this lab, we create a data table. We record the name of the dissolved substances, their concentrations, and their corresponding pH values. We have several common solutions, and we will measure the pH of each using the pH meter. This helps us observe how different substances affect pH. Now that the experiment is over, it's important to dispose of any waste properly and clean glassware to prevent contamination in future experiments. When disposing of waste, make sure to follow your lab guidelines. For this experiment, any waste we generated could be safely disposed of in the sink with running water. It's crucial to rinse your glassware thoroughly to remove any leftover chemicals. Even small traces of chemicals can contaminate future experiments and could lead to inaccurate results. For glassware cleaning, we use soap and water to remove any residue. A brush can help clean the inside of beakers, flasks, and cylinders more effectively. Cleaning your glassware is also important because it helps prevent chemical buildup that can alter the results of future experiments.
Okay.